with lesson 1A-4, symmetry. So in symmetry, we're going to just explore a couple of the basic types. Line and point symmetry, keeping it one, two-dimensional type thing. There's other types of symmetries out there. Some of them can get rather complex and have a lot of implications in your calculus and beyond courses, including physics, biology, and so on. But we're going to keep it pretty basic. First one we're going to look at is symmetrical with the x-axis. And I could have made this y is equal to 3, y is equal to 5, or whatever, and just done the same thing with the translation, but we're not going to worry about it right now. So all we're going to do is we're going to take any point AB on this parabola here, and we're going to reflect it across the x-axis. Well, basically, if you remember in geometry, you just took this and did a perpendicular bisector. This and this length is equal, and that's perpendicular. And down here you have A negative B. So all you're doing is just negating the y coordinate. So if I wanted to construct this, I would take any point here, reflect it across, perpendicular, and I'm just eyeballing it here, and I would have something like this. That's just reflecting. For the y-axis, something very similar. Here's another parabola, a little bit more familiar because this is a basic quadratic. And I would have a point over here, AB. And this time, I'm going to reflect it across the y-axis, so it's the x-coordinate that's going to be negated. That's going to be point negative AB. And you remember some of the properties of quadratics about the directrix and some of the relationships with any point here. And we're getting into the basic definition of a parabola here. But we're not going to be just limited ourselves to parabolas. We're going to expand ourselves to almost any type of graph. So again, perpendicular here and bisected. And we're going to just flip it across the y-axis. Same thing here. I could take any point, come straight across, and reflect by negating the x-coordinate. About the origin, we're going to negate the x and the y. So I could take any point here, call this AB. And what is really going on here is I have a double reflection. I'm going to reflect across the y-axis, and I'm going to reflect across the x-axis. I could have done it in the other order. I could have done x, then y. It doesn't matter. You would come up with a nice, good rectangle here. So I'm going to go this far across and this far above. So I'm going to go that far above, and I'm going to come up right here, and I'm going to have negative A, negative B. And here's an example of one that's already been given to us, just negating the A and the B. But we're going to focus mainly on algebraic issues because we're not going to always have the graph. And this is one reason why having the parent function graphs can be beneficial to you, because a lot of our parent functions do have some symmetry involved. So we're going to look at, with respect to the x-axis, we're just going to solve the equation for x and get an equivalent equation. That's a big deal. Now, if we go across the y-axis and think about what we did that. We basically replaced the y with a negative y. And here, for the y-axis, we replaced the x with a negative x. And here we replace the x and y with negative x and y. So that's all we're doing here. And we're going to see if we get equivalent equations. All of these need to be equivalent. So let's go ahead and take a look at a couple of examples. So our first one is a basic parabola, quadratic. This is the parent function. So if you have that picture in your mind, you know already it's going to be symmetric around the y-axis. And it's not going to be symmetric around the x, but we want to algebraically demonstrate that. That's the objective of this problem. So the first thing you're going to do is to remember on a quadratic, you're reflecting and changing the, for the x-axis, when we cross the x-axis, you're changing the y-coordinate. So what we want to do is we're going to solve for x. You can solve for x before or after and see if you get an equivalent statement. And we're going to change the y. So we're going to have negative y is equal to x squared. All right, so that's a test. Then we're going to solve for x. So first thing we're going to do is we're going to take the square root. We can write this like this if you wanted to. A is equal to B is B. Okay, that's the symmetric property. So we're going to go ahead and take the square root. X is equal to both roots, negative y, or x is equal to plus or minus yi. All right. Well, these are not equivalent statements. When we have x is equal to plus or minus square root of y is not the same as x is equal to plus or minus square root of yi. So that would be a no. But y-axis, of course we know the answer. Remember our quadratic parent function, but we're still going to make the test. So when we're reflecting across the y, we're changing the x coordinate. So here we have y is equal to x squared. Now we're going to solve for y on this one. And it's already solved for y, so we don't need to do much. So we're just going to replace it with negative x squared. And of course we get y is equal to x squared. These are the same, so it is a yes. Okay? About the origin, it doesn't matter which one we solve for, x or y. Well, we just got it already solved for for y. So we're going to have negative y is equal to negative x squared. So negative y is equal to x squared. These are not the same, so it is a no. Next example. So here we have x is equal to y squared. Now again, we can, this one, when we're solving for the x-axis, we're solving for x equal to, all right? And we want to get equivalent statements. Well, this one's already solved for x equal to. And if you remember, we're just going to change the y to a negative. 1 over y, negative y squared, and we get 1 y squared. These are the same, so yes, we're good. All right? And if you remember, it's kind of not quite something we practice a lot of. This graph kind of looks like this. All right? Kind of like that. All right? So think about it. We're reflecting across the x-axis. Now, of course, when we have a visual representation, we can automatically say no for the y-axis. But let's go ahead. The objective is to demonstrate, to prove algebraically that this is not symmetrical with the y-axis. We just don't want to blanket answer, oh, because I remember the picture. So what we're going to do here is we're going to solve for y. We can do that first. So we have x y squared is equal to 1, and y is equal to 1 over square root of x. Okay? So we're just going to replace the, since we're reflecting across the y-axis, we're going to replace that with a negative x. Y is equal to 1 over square root of negative x, or 1 over xi. These are not the same, so this is a no. And of course, again, we know this is going to be a negative here. And it doesn't matter which one we solve for. We're going to replace these with the opposites. And we get x is equal to 1 over negative x y squared. And that's going to be a no. So you're going to be doing this on a few of the problems. Now, real quick, I just want to demonstrate y is equal to x, the parent function linear, is symmetric about the origin, because I can tell you negative y is equal to negative x, and I can divide by negative 1 if I wanted to, because we're going to solve for one of these, and we're going to get the equivalent statement. All right, so I'm going to go ahead and get this one posted, and then move on to the next one.